All right. As a side note, so I am currently, as people who are just joining in, the people who heard already, I'm in rural Michigan in a house right now that has gotten internet in the past, I'm going to say 2 years, like just got it before COVID. So if I go out for whatever reason, if I start bugging out, please let me know. If I do, as always, if I do it completely log off, please wait for me at least 10 minutes. But if I am bugging out, the recording that will be unbuggy will always be on the YouTube channel. All right, with that disclaimer in place, let's get started here. All right, as always, we got our announcements here. First things first, and making sure that I am not missing anything because there's a lamp in my way. There we go. Awesome. Announcements. Assignment number 2, that is due, I believe, someone correct me wrong, is that due today or is that due? No, it is due next week. Is that correct? The 4th. Yeah, the 4th. Thank you. Because Monday is a catch-up day, so there will be no lecture. So make sure you still go to your small groups, but don't come to me. Go directly to your small groups. Catch up on that assignment 2. Make sure assignment 1 is definitely done. That should be finished and complete. If assignment number 2 is troubling you in any way, as always, reach out to your fellow classmates, reach out to your colleagues, reach out to your TAs, TFs, reach out to me. Anything you want to do there. But make sure that you are comfortable with the concepts in assignment 2, because assignment 3 is right around the corner. We'll start building upon it. That's all I have for announcements today, though. So any questions there? Anything about no class Monday? Anything before we get started?
Now, you're not talking about the 27th, right? You're talking about the 4th?
The 4th, yes. Assignment 2 is due on the 4th.
Okay, so not next Monday, but next Monday?
Next Monday, yes. I actually don't know what the 4th is. Yeah, if that's next Monday, yep.
Yeah, the schedule shows that Thursday is the catch-up day, not Monday. I mean, the calendar online.
Does it? Okay. That calendar, I think, was corrected, like Greg warned me about. So let me double check there. If the calendar says that, then disregard this announcement, because that means that we will have lecture on Monday. So I'll send out an announcement right after this. I wish I had my pen and paper with me. I'll send an announcement right after this. I'll confirm with Greg whether it's Monday or Thursday. Sorry about the confusion. So yeah, thanks for that call out. I'll double check on that one. Actually write a note here to myself so I remember.
I have a question that I just thought of that I've
Amy, what's up?
wondering for a while. Okay,
Sure.
so if we aren't able to pass this unit and we were to want to try again, would we be able to just request to start at unit 2 for the next session?
I don't exactly know the specifics. I would recommend reaching out to Greg and talking to him about it. I believe, take it with a grain of salt, I believe that if for whatever reason unit 2 couldn't be completed, you reapply, and I think you start at that, but I don't know for sure. So talk to Greg about that one.
So do you think if I didn't pass, I'd be able to start at unit 2 after I reapply?
I can't confirm anything. I would not know.
Okay.
You'll have to talk to Greg about that one.
Okay, thank you.
Yeah, absolutely. And great question too. So yeah, talk to Greg if for whatever reason you don't feel you can complete unit 2, check in on him. But as always, also talk to Taylor too. If you feel like there's some parts of the units that maybe you're not comprehending or time management, also reach out to Taylor that we saw in last lecture, our success coach, and she can also help out too. All right.
Okay.
Fantastic. All right, everybody, let's get into this thing. As of today, we are going to be making a cake. Yes, cheesecake is on the menu. Let's talk about cakes here. When we're baking a cake, how would we bake up a cake class with a sweetness scale class variable? Someone talk me through this. What do we need to start with? Help me build this cake.
Public.
I'll take it. Public
class cake.
Public class
Public
cake.
class
Is
cake.
cake, I love it. Is cake lowercase or uppercase?
It's uppercase.
It's uppercase because classes are always uppercase. Fantastic. Keep talking me through it. We need a sweetness scale class variable. What do we do there?
Private string. No, this is scale. Private int.
In?
Very good. Yeah,
Sweetness
awesome job.
scale.
Yes, it is int.
Sweetness scale?
It is definitely int. Yes, so private int sweetness scale. But also, remember, when you're coming up with these class variables, it's about how you want to use it. So if it has to be a string, because there's somehow a character in there, it has to be string. Maybe you want more of a rating. Maybe you want a 4.4 or something like that. In that case, it would be a double or a float. That's why I just chose in here. It's arbitrary. But remember, when you're designing your classes, it's all about what you're going to be using that variable for. That dictates the data type. Awesome job, everyone. Let's keep going. What if we wanted a constructor to set the class variable, that sweetness scale? How do we do that? Talk me through it.
Public cake. No, wait.
I like your answer so far. Keep going.
It is right. Public cake. And then inside the constructor. This dot sweetness scale equals
Very
sweetness scale.
good.
Got it.
Absolutely. So yes, we go public because constructors for our classes are always public. And then we say cake directly. We don't have a return type. It's not a method. This is a constructor. We don't have a return type. So we go directly to the name of the class to build that constructor, cake, capital C. And then as the question said, we want to set the class variable. In order to do that, typically we need to pass it in through the parameters. So we pass in that sweetness scale as a parameter and then set it with that exact keyword that you said, this, THIS. It's a very powerful keyword. It means the context of the class, whatever's inside the class. So we call that sweetness scale class variable and set it to whatever was passed in through the parameters. Fantastic. Any questions about this so far? All right, let's keep going then. Let's keep baking. What about a getter for it as well? How have we needed to create a getter for this sweetness scale? Talk me through that one. Come on.
Public int.
Very good. Public int. We need that return type. Awesome.
Get sweetness scale.
Very good. And then what? What's inside the method? Do we take any parameters in?
No, I don't think so.
No, we don't.
No.
We do not. Not in getters. We don't take, because we're just getting information. We
Yeah,
don't
it's
need to
a getter.
provide it. Get that information. So what do we have to do then in that method? What are we going to do at the end? What does a getter do?
Return the sweetness scale.
Very good. It's going to return the sweetness scale. Fantastic, everybody. So that's what we have to do here. This is a getter. Awesome. Any other questions about this? All right, let's keep moving on then. What if we wanted to add a taste method? In this case, and this one is more of a rhetorical question. If we wanted to add a taste method, in this case, what we're going to just do is say public void taste. And as always, these are our typical examples. We're going to do system out print line and then say, oh, what kind of cake is this exactly anyway? Because we just said cake. Well, it could be confetti cake, it could be cheesecake, chocolate cake. We don't exactly know what it tastes like. It's a very arbitrary name for a class. Typically, like we said in the last lecture, these are typically abstract. If that was coming to mind, like maybe I should make this an abstract class. If that was going through your head, awesome job. Right now, we're just going to keep it a normal class. We're not going to get back into abstract classes right at this moment. Instead, we're going to make it a little bit more complicated. We're going to make some fun here. This is a very generic, a very generic cake class. So let's make something more specific. I'm going to make a chocolate cake. Oh my gosh, I'm falling apart. If I wanted to take in what I just made for that cake class, what do I need to place here in my code? I want to take in all those methods and parameters from that.
Extends cake.
Very good. It should be extends cake. Awesome, awesome. Okay. Extends cake, fantastic. So if we continue going here, what do we need to build? Once we extend that, looking over here on the left-hand side, we're going to get an immediate error if we do this. So what do we need to add in order to get rid of that error?
You have to build a constructor.
The constructor, what is it going to look like?
I want to say, hold on.
Okay, this one I'll actually
The
give to you. I'll give to you.
Super.
I like this. I'll give it to you. It's public chocolate cake int sweetness scale I'll give you that. But I keep hearing this word. What needs to go inside that constructor if we're extending cake?
Super.
Very good. We need to use super. But what else do we need to put inside of super? Take a look at our left-hand side. What does cake's constructor ask for when we phone home?
The sweetness scale.
Very good. I'm exactly right. We need to put in the sweetness scale inside of that super. Remember, super is used to phone home when we're building up this class. So we need to put the data that it asks for when we send back information to our parent class. In this case, if we're looking at cake, it's asking us for that sweetness scale. That's why we do it this way. Additionally, what I want to do now is that it's a chocolate cake. So I'm going to build another taste method here. In this case, I'm going to say print system out print line so chocolatey. Because now we know what kind of cake it is. I can actually do a accurate taste method here. I know what it's going to taste like, so I just put that out there. Or this is just an arbitrary example because about a year ago, I was extremely hungry and just thinking cake. And also I watched the greatest British baking show for the first time ever, which by the way, changed my life during COVID. Never baked a cake ever before or after that show, but I digress. Anywho, I created this taste method, but I'm missing one thing. What am I missing? I extended cake, but I'm missing one big thing here in this class. What am I missing on that taste method in particular?
Is it the override annotation?
Very good. It's the override annotation. Remember, we extended cake, and therefore we overrid the cake or the taste method in the cake class. So absolutely right. Yeah, we needed that annotation. Fantastic. Because when we transition that taste method over to our class, you have to make sure that we're telling our compiler, we're telling Java, hey, I know what this cake tastes like. Get rid of that, what is this cake exactly, print out and tell them that it's chocolate because I made a chocolate cake. Awesome, awesome. All right, let's talk about something a little bit more specific now. This is my favorite. Excuse me. Actually, allergies are better up here in Michigan. This is my favorite meme when I was making this, and I still remember this. I was like, this woman is my spirit animal. Look at that. All right. I want to talk to you all about more cake, and specifically our taste method there that we just did. Cake, the cake class, we created that taste method, and it just printed out, oh, what kind of cake is this exactly? A simple printout. Again, we had to print that out because it was an arbitrary name. We don't exactly know what every cake tastes like. There's no taste for that. It just tastes like cake. So what we did, we made something more specific. We made the chocolate cake class with that taste saying, oh, so chocolatey. But what if we made my class for my favorite cake that, again, it was already called out, thank you very much, Chris, was cheesecake and taste and that, oh, so sweetney goodness. We have a parent class, cake, but we made two specific classes, chocolate cake and cheesecake. And then we customized those taste methods to be specific to those specific cake types, those specific classes. This is called polymorphism. To make those methods from your more general parent specific to what they need to be used in your specific child classes. Polymorphism. So whenever you saw this word, which I thought was a Yu-Gi-Oh term, all it means is to customize your parents' classes to your children's liking. Not every single class that your parent provides is going to be fit for you, aka fit for your child class, and therefore you want to customize it. When you do that, you're actively participating in polymorphism. So I will pause here for, let me go. I have one more thing here. Using the same method to do different things. So I'll leave it here for just a quick question. Anybody have any questions about what polymorphism is? Polymorphism is not anything different from override. Override is a tool, an annotation in JavaScript that allows polymorphism to occur. Polymorphism is a term, or basically what we're doing, the action of customizing those methods. Override is the tool that allows us to do so. So you can think of override allowing polymorphism to happen. Basically, override you can do with a bunch of different parent classes. I'm trying to think of a better way to phrase this. essentially override is the tool in which you'd want to participate in polymorphism with, but I see where the possible confusion is what they're saying. They're almost kind of synonymous, except that polymorphism is typically with parent to child classes that you've created, and also doing two different things. So hopefully that didn't confuse you more, but let me see. Sorry, there's like a lamp. Like,
I also have a question. So override is basically okay, for lack of better terms, it's basically the path that we have to use in order for polymorphism. So polymorphism is the action for override.
Yeah, basically
the connection.
Absolutely. So overriding a method means that you're going to change it to something specific.
Yeah.
So you can override abstract methods. You can override things that are in interfaces, things like that. You can customize it to that. Polymorphism is the action of taking a parent method and customizing it to do something different in a child.
Okay.
So they're very, very similar. And honestly, I'm going to look up a better way to describe what the actual differences are. But essentially, they're so close together that don't think of them as two different things. Think of them as very much working in unison typically, or at least very, very similar to each other.
Okay.
Yeah, I'm going to see if I can get a better one for that, because that actually is a really good question, because I was thinking, I was like, yeah, what is actually the true definition of the difference between override and polymorphism? I do know polymorphism works with those classes that we create, those actual classes of the parents and the children, and override is also with just like native stuff. So let me see. I have one more question here. So a method is under override polymorphism. So a method that is under override / polymorphism is private and can only be used within a specific child class. No. So as we can see, even what we did with taste was a public method. So no, the accessor will have nothing to do, or the access level will have nothing to do with the override or polymorphism. Actually, every single example we've done so far with the equals and the toString, and even those taste methods that we did with override, were all public. So let me know. Yeah, I'm sorry, Andrew. Let me know if you want to talk to me too, or just retype it. Let me know exactly what you're getting at there. But also, if that also was the answer you're looking for, let me know too, just so I know what's going on. I see a few more people typing, so we'll hold on for a moment. That was the answer. Awesome, awesome, awesome. Give it a few more seconds here. Giovanni, if you just also want to speak to me too, feel free, or type, either one.
Oh yeah, no, so I was just thinking like, so in a technical sense, inheritance is something that you do in order to extend or impose certain characteristics into another class. But in an abstract sense, it serves polymorphism in that it's just another tool that allows it to kind of happen, or for you to do it.
Yeah, exactly. So abstract classes are there to provide a structure for children. So abstract classes, of course, can't be made into objects. They can't have instantiations, but they pass down those algorithms to their children, their methods to their children. That's why abstract classes are so powerful. So you don't have to redo your algorithms class to class. Say maybe, yeah, oh, we won't go into those examples that were last time, but if the method has to stay consistent between children, that's why abstract classes are so great. But what if you get to that edge case, that one situation where your parent's algorithm just isn't sufficient for the child in that one case? That's where polymorphism comes into play, or override, where you can override, or sorry, that's where override would come into play, so you override it for that specific child. I believe polymorphism, and take it with a grain of salt here, because I do want to look up more specifically those differences between the two, but polymorphism would be to customize each child's method to do a different function between each child. So
Right.
To answer your question, abstract, and I completely got off your point of your question too. I guess detail me what portion that I'm still missing to help you out.
No, I guess I'm just trying to like flesh it out. So I mean, I guess you can have polymorphism with interfaces, let's say, when you just create a bodiless method, right, that you can implement. But I guess what I'm just trying to understand it in my mind. So, but when you're extending, or you're like a class is inheriting something, it kind of allows, it's sort of like piggybacks, like it allows you the opportunity to override those things. Like they just kind of work in tandem in some ways. Like you can't have one without the other necessarily.
Correct. Yeah. So basically, that's kind of what the conversation has been around. And I want to get more granular with that. I just cannot, and I feel bad that I just have that gap there. That yeah, basically in hand to hand, override and polymorphism are together. They work kind of in tandem. But let me get a better explanation on that, and hopefully next class I can offer a little bit more clarity around the true differences, if any, about the two. So hold on to that, and let me see if I can get more information. But in the end, know that the definition between the two are so similar that overriding and the action of polymorphism are very similar. So yeah, great call out, everybody. I love that question. I didn't get that question last unit, so no, I want to get more in depth about that. All right, so let's see. Okay, Andrew, that'd be a way of thinking of it. So if you want to customize your cake, so one with white sprinkles and the other one with black sprinkles or something like that. Awesome. All right, let's keep moving forward here. Let's go into a true or nah. First things first, abstract methods must be overridden by child classes. Or sorry, abstract methods must be overridden by children classes. True or nah?
True.
Nah.
Very good. True. Well, this one, you can create instances of abstract classes. True or not?
No.
Nah. When overriding a parent class method, you are utilizing polymorphism.
True.
True. That is true. In ancient America, it was believed that keeping a fruitcake under your pillow would give you a handsome husband. True or not?
I'm gonna go true. I don't know.
That is true. It is true.
That is some random stuff, man.
And that same fruitcake gets passed
What are they
around
getting
to
from you up there?
Generation to generation.
A fruitcake? They couldn't pick anything else? A fruitcake?
Oh, Lord.
Oh, my
Be
God.
like, I heard Susan make good fruitcake.
A
I don't know about handsome husband, but I know about roaches. That's what it would have got.
Oh my
A
God.
fruitcake, man.
That's how
Excuse
you
me.
get ants.
That's how you get ants. There you go. Yeah. It's all about priorities, people. It's all about priorities. Roaches, like beautiful partner, like whatever. You gotta weigh it. You gotta weigh it. All right, let's keep going here. Why do we do this? Chocolate cake, or why do we exactly do the polymorphism? Why do we do everything like this? Chocolate cake, choco goodness equals that new chocolate cake 8. Remember that 8 is that sweetness scale that we were talking about in the beginning of lecture. Then we have our cheesecake, happiness on a plate because it's cheesecake. So why we do this abstractness is that we already saw this last class, is that we have an array list of cake. We have a list of my cakes there. This right here, as we discovered that we could use the general version of cake and place it into the array list. That's what we were able to do here. So I can put in chocolate cake, I can into there by just saying mycakes.add choco goodness. Remember, we use this parent class, this abstractness, so we can basically make an entire collection of one type of object using a general class. Let me go ahead and do this. Sorry about that. There we go. If I wanted to add a cheesecake, I could also add cheesecake in there as well. I made this slide not thinking that we were going to go over it last lecture, but I wanted to still remind everyone that this is possible. And not only possible, but this is one of the most powerful parts of Java and why object-oriented programming really does help us out. So what we did at the next line is we added our happiness on a plate, our cheesecake class, to our cake array list. So the question is, how can we taste each of my cakes? And my question to you is, how exactly do we do this? what tool do we use in our for loop to do this? By the way, this is a for each. How are we going to taste each cake? Anybody know how we can iterate through our array lists using that for each? What do we put on the right-hand side? Anybody? What do we do here? Anybody just want to take a stab at it? I won't bite, pun intended. All right, what we do here to loop through an array list with a for each is that we just place the name of the array list on the right-hand side, what we want to iterate through. Oh, did I mute you? Oh my gosh, I am so sorry. I thought I unmuted you. All right. I was like, why is no one talking to me? I know you guys want to do it. There we go.
It wasn't the right answer.
He's invaluable.
Thank you. I'm sorry. Sorry. Get out of your system. Yes, I'm sure you all had it right. Perfect. Thank you. I apologize. That was my bad. All right. What we do on the left-hand side, though? Tell me that. What is that cycle?
Cakes.
Cake. Very good. Cake. We're going to use the cake class. We have to keep the general class because if we look in the array list, we use the general class up there. We have to do it in the for loop as well. So we absolutely do that. But this is the fun part. Because we know that taste is a method within our parent, we know that our children share it. So all we have to do is do cake.taste in order to just run through those. So real quick, so we can actually see this in action, let's go ahead and hop into IntelliJ and actually see this going. So what we're gonna do is just build this right from scratch. We're gonna do Java class, say cake, right like that. We're gonna make that sweetness scale. Is our class variables private or public?
They're private.
Very good. We have private int sweetness scale. Awesome. We won't define it to anything. And then what do we do next? What's our next thing? We go class variables. What's the next thing?
The constructor.
Constructor.
Very good. Constructors. And talk me through building this constructor for the cake class. We're going to be taking in that sweetness scale. Very good.
Public cake.
Cake.
Awesome.
Sweetness
And-
goes in.
And sweetness scale.
Very good. And then what do we do? How do we assign that class variable? What keyword do we always use?
This.
Very good. This.sweetness scale equals sweetness scale. Awesome. Awesome. Great job, everyone. And then the final thing, we always have our getters and setters. We don't need to do that right now. What we care about is our methods for the taste. So I'm going to go ahead and write that. So we said public void taste. And then system.out.println. What is this? Because we don't know what it actually tastes like. Perfect. So we're going to move on now and go ahead and build our, our chocolate cake. Now for this one, what is going to save us a bunch of time that we don't have to recode everything? What are we going to put in this class the second we begin it?
Extends cake.
Very good. Extends cake. And just like that, it just saved me a bunch of time with writing some stuff. But it's giving me an error. What do I need to do here to fix that error?
Build a constructor.
All right, talk me through it.
Public chocolate cake.
Chocolate cake.
Very good. And taking that sweetness scale. Awesome. And then what do we put in here?
Super.
Super duper. Awesome job. Sweetness scale. There we go. And then finally, we're going to customize that taste. What's the first thing I do when I'm customizing a class?
Override.
Yes.
Very good.
Override.
Public public void taste. There we go. System.out.println. Choco goodness. Very good. All right. Last things last, we're going to go ahead and do the cheesecake, and I'm going to do that for you guys because you have been awesome. Cheesecake class. Why did I just call that cheesecake class? Oh my gosh. If you rename something wrong, I do recommend going to refactor, then pressing rename. That will change everything in your application to that new name.
Yeah, I have to refactor a lot.
Remove that. Move that. Go. Copy that, paste that. There we go. Move that back one and 6 stones cake. Cool, cool, cool. Sweetness on a plate. Awesome, awesome. All right, my question to you is, okay, now I need a starting point in my job application. What did I always say that the name of the class that you put your starting point in was going to be?
It's a program.
Program, very good, absolutely. We can start seeing that more and more. Program. Yes, I believe so. Who remembers the starting point from scratch?
Public static void main.
Very good.
String.
Main.
Bracket.
Awesome job. I love it. Awesome job, everybody. All right, let's go ahead and see that array list thing in action. Let's say cake. There we go. My cakes equals new array list. Awesome. There we go. And now I'm going to create 2 cakes. I'm going to create my chocolate cake. Chocolate cake equals new cake. What's the sweetness scale for a chocolate cake?
10.
All right, 10 it is. All right, and then we have a need to make a cheesecake. There we go, cheesy. I didn't spell it right, cheesy. What's new? What's that about a cheesecake sweetness scale? What's that one?
It's a 5.
5? No.
7 or 8.
I'm going rogue. I'm going to a 7. Definitely a 7. All right. How do I add these 2 cakes now to my class? Or to my array list, excuse me.
My cakes.
Very good.
Add.
Awesome, awesome. Yes, that
And
add method.
Chuckle.
Yes, very good, everyone. Add cheesy. All right, now the fun part. Talk me through how we're going to taste each of these cakes. What are we going to use?
For each.
For each.
For each.
So I will be nice and I will start it out for you with that 4 there. What's next? What do I need to put here?
The key.
Yeah, true.
What is it? Cake.
Cake.
All right, what's next?
The colon, my cakes.
Colon, very good. Yes, that colon dictates a for each. And I'm going to say cake dot taste. Just like that. Fantastic, everybody. Great job. I'm going to press that, press run. And here we go. Here's some code. Let's taste some cake. Everybody needs a snack here and there. Awesome. Sweetness on plates, chocolate goodness. Good. We're seeing different customized outputs. We are now seeing a true example of polymorphism. See, I promise it wasn't as scary as everyone thought. It's kind of scary still, but whatever. There we go. Any questions on the code that we just saw? Graham, I just saw your question. Why call it program and not main? I mean, technically you can. It's whatever your standard is or who you're working with. Typically, when I've been working through Java applications from team to team, program seems the most consistent, and it's really just because one nerd one day just stood up and is like, we're gonna do program, man. That's it. We're not gonna do main. So if you like main, go for it as long as you know what's in there. But I know program is the most usually the most adopted, but it all depends again on the environment. I'm sure that other people on the call, TAs, TFs have different says, but I see program the most.
Kyle, could you break down the left side of the for each loop on line 13? The cake. I know the first cake is the class cake. What's the second cake?
So right here?
Yeah, right there.
So on a for loop, when we're doing integers, what does a for loop do with integers? Not looking at this one at all. What does it do with the integers?
Iterates over them.
It goes 0, 1, 2,
oh, yeah.
3,
0, 1, 2, 3,
right?
right?
So I changes to 0, it changes to 1, it changes to 2, depending on the iteration. Remember, there's no magic. It's going sequentially, and then that loops over it 10 times, or however long your for loop is with I. Remember that I always changed the number. Same with cake here. Cake is basically your I, but instead of being a number, it's the iteration through the array list. So at the first iteration, it's your choco cake. At the second iteration, it's the cheesy cake. So remember, for loops go in iterations, line by line, depending on how many are in there. So that's why we see it on 2 different, excuse me, that's why we see 2 different cakes on 2 different lines, because it iterated it twice. Once over choco cake, once over cheesy. Does that kind of help?
Yeah, I see it now. It clears
Awesome,
up.
awesome.
Yeah. Thank you.
Yeah, absolutely. All right, any other questions before we keep going? All right, let's go back and see what else we got on these slides. All right. So we're gonna go through a more real world example here. So what if we had multiple client credit cards that we needed to change? So maybe we're not talking about cakes here. We're trying to buy our cakes. So we actually need credit cards. Let's start with the first one. We have a Visa credit card for client number 1 equals new credit card or Visa credit card. And then we have a Master credit card, client number 2 for a Master credit card. So right now we're just talking about why exactly do we do this generalization inside these array lists? Why is it so powerful? Well, let's take that array list, for example. What if we have a credit card class, a generic credit card class, and we make an array list of them? In this case, we're going to place client 1 and client 2 within that array list. But the best thing about this is, what if you had 1,000 clients? Because one day you're all going to be successful developers, you're going to have clients on your side, but you don't want to have to go through and do invoicing. Trust me, it's a nightmare. So why not build a program that does that for each different credit card? So what if we wanted to charge all of our clients, our 1,000 clients, in one swoop, in one for loop? That's why this thing is so powerful, because the credit card class has maybe a general charge class to it. Because MasterCards, Visas, Discovers have different way of charging that credit card. So we can customize those charge methods depending on each class, whether it be Discover or whether it be Visa, using polymorphism. But then we can use that general class within the array list to charge all of our clients at one time, because they all have a charge method. We know that because the credit card method has that. The parent has a charge method. Again, what I'm showing you here is kind of more of a real world example of what is actually out there for either whether it be healthcare systems or literally finance or consulting work. This is what makes Java so powerful in this object-oriented programming kind of technique. So any questions on this and why polymorphism truly exists or why we do it?
Is there a way to add, like if you have 1,000 clients without doing .add for every single one?
Technically there is. When you are instantializing your array list, you can actually place it within your, up here, and I believe, oh, I forgot what the true annotation is. I think if I do it this way, this is a fun one. I think it's with curly brackets though, or with square brackets. I think it is square brackets, isn't it? Technically you do it this way. Should be more fun. If you didn't want to do that, I forgot what the actual, the thing is, but you can put it inside of there. Oh, what is, jeez, I forgot what it was exactly. But yeah, technically you can do it all within one line. I think I have an example somewhere in one of the lectures about it. But in the end though, if you don't have all of your clients at one time, unfortunately you do have to do the .add, because you can only add it when you have the information or when you're creating the array list. Great question. Okay. Good there. Any other questions? I'll pull back up Slack. Come back. There we go. All right. I think we're good. All right. Let's keep on keeping on. Let's talk about some standards here. All right. Bringing in the cake as always. We already know what our structure looks like. It's chocolate cake and cheesecake. Nothing different about that. But we need a way for our judges to react to our tasty treats. So we're going to go ahead and work with this. But in the end, if you've ever watched the Greatest British Baking Show, it's not all about cake, unfortunately. There's also pie. There's also pie. But pie and cake are very similar to each other in the fact that they're both desserts. So what we want to do here is that we're kind of creating more of a structure now for all of our tasty things here for this lecture. So in this example, what we're going to have is that we're going to have a judge's reaction method at the very top level for the dessert. And what we want to do is that somehow we want to we can't just say judge this dessert. The judges have to actually know what kind of dessert is it? Is it a cake or a pie? So because dessert is so generic, in this case, we're going to be making it an abstract class. Because again, they can't just judge dessert, they have to know more specifics. And they judge each kind of dessert a little differently in different ways. But one thing we do know is that we don't have any idea how they're going to judge a generic dessert. Think about that for a second and stick with me. I promise. I'm actually making a point here. A dessert can't be judged in a baking competition, just a general dessert. They have to know whether it's a cake or a pie because they judge it specifically on that. So we don't have any code to actually add to this judge's reaction. We have no way to write this method. We don't have any idea what to do here. And if we even did write some, it'd just be a waste of space. So the question is that, okay, should dessert technically be an abstract class? Or should it be an interface? That's what we need to talk about today. Is essentially identifying when we should do interfaces and when we should do abstract classes. Let's go ahead and dive into desserts. So for abstract classes or interfaces, let's go ahead and talk about the differences. For the abstract classes, we want to provide some structure. As we already know that inside of our abstract classes, we have code that we can actually put in there. We know some general code that we could provide to our children in the future that they can work with. So that will help us define that functionality to the children, to our children from our parents' class, and then their generations after. Continuing on, basically you must have these methods and do the bare minimum to do this. That's what an abstract method is saying. You must at least have these methods and do this functionality. Abstract methods. Continuing on, for interfaces, what this is more about is creating a contract, aka a list of methods with no set functionality or expectation. The only expectation is to have those methods. Looking at it a little bit closer, we need to, again, establish a general contract with all of our children classes. That's what interfaces are there for. And basically, if an interface could talk, at the bare minimum, you must have this method, but you completely decide what it does. So let's take a look at these. Abstract classes are something that you can provide some general default structure on, while interfaces are providing a contract. You must at least have this kind of functionality. Now, if you're asking yourself, okay, interfaces though, I do know they have default. Why, I mean, technically I can provide functionality there. If you're providing a lot of defaults and interfaces, you might want to consider going back over to abstract classes. Default is there just for a backup plan for interfaces to provide some default functionality, though it is kind of rarely used. In that case, you typically want to go towards the abstract side. All right, let's dive a little bit deeper into it until I open it up for questions. So choose this one, choose abstract classes. If your parent requires you to create class variables, that's another big thing, is that abstract classes only have class variables while interfaces do not, as well as they can have private methods. And have also private methods that everything can, that your protected and public methods can't interact with. And then finally, complex functionality, longer methods should go inside of the abstract class. So if your generic class needs to have class variables in it to hold data, if it needs to have private methods to do extra steps, or if it has complex functionality that you want to provide to children, then it's definitely an abstract class. Looking at the other side, for interfaces, if your parents require only public methods, if you're if you want to have public static final variables, aka constants, to your children, you do an interface. Again, we can't just have class variables inside of interfaces, that's not allowed. And then finally, simple functionality, those defaults that we were talking about. You can provide simple functionality inside of these things, but if you're going very complex, or if you want to do a lot of extra stuff, those are not for interfaces, that's for an abstract class. Remember, in the end, these two structures that we're talking about are to share code with children. To share code with children. This is going to alleviate a lot of coding into the future and set standards for your structures, for your classes. You don't want just your developer to go off the rails and develop a cake however they want. You don't want a cake developed like an orc in a video game. You want a cake to be a cake. You want an orc to be an orc. You want your class to have the structure that you intended to have in your application. That's where abstract classes and interfaces come into play. Now, looking at these two, first, any questions about what we just talked about and the differences between them? And also, does anyone have any ideas exactly about what dessert should be after a conversation, whether it should be an abstract class or an interface? I'll take answers to either of those questions.
An interface.
Absolutely, it should definitely be an interface. Awesome, awesome. Yes, we are going to develop this dessert class to be an interface. Now, before we continue moving on here, I'm going to hold it though. Any questions about the difference between abstract classes or interface, or does everyone feel comfortable with that? There's going to be a test here soon.
So would like a cake class be an abstract class because it's much more specific?
Technically, yeah, absolutely. And then you can implement that interface into the abstract class. I'm reminding myself if that's, yeah. Yes. I'll double check that, yeah. But yeah, absolutely. So yeah, to answer your question, yes, cakes should definitely be an abstract class because we have functionality that we can define for them and a class variable. So yeah, absolutely. Great call out.
Can you put an abstract class in the interface?
No, you cannot put abstract classes into interfaces. Interfaces are general contracts by themselves and can be implemented into classes. Think of interfaces as barely even code. I mean, technically, yes, of course, they're code, but they're very, very cut and dry code. They're a contract for your children to abide by. And we'll see an example of it here soon. All right, let's keep moving forward and we'll see if we get more questions out of you guys. All right, so knowing that this is going to be an interface, now we have to kind of design for it. We know that we have one method, judge's reaction, so let's go ahead and start doing that. To create an interface, we use the keyword interface. The accessor will always be public, just for the reasons why classes are always public. If you make them private, we can't use them within our code base. So public interface dessert, keyword interface. Now, the one thing our directions told us is to create the judge's reaction method. To start doing that in our interfaces, what we do is we say void judge's reaction. This is going to be able to create a contract with anybody who implements dessert to tell them you have to create your the judge's reactions method within yourself. To show you a quick idea, or to show you a quick thing about default, say we wanted to create a score application, or sorry, a score method. Here we would just say int score return 10. This default here tells Java basically you're creating an interface method with some very small functionality within it. Again, if you get to complex functionality, you do not want to put that in interface typically. You want to bring that to an abstract class. But if you want to put some small functionality into it, you'd use the keyword default within interfaces. So basically, after you do this, it is technically optional to define this. You do not have to redefine score. However, you probably want to redefine score since that's the way you're going to be doing your judge's reaction. So, and then finally, this one must be defined in the children's classes. If you just put a semicolon at the very end, this is going to force your child to actually do it. So let's go ahead and see this. How exactly do we bring in interfaces? Does anyone know who read the material? How do we bring in
implements?
Very good, absolutely right, awesome. So if we wanted to bring our dessert into the cake class, like we've been talking about for so long, we'd say public class cake implements dessert. In that case, all the code goes there, but the keyword we're looking for is implements. That's what we're looking for right there. That's how we're going to bring in all that code base. All right, let's go ahead and see this in action. What we're going to do is go back over here. We're going to say source, new Java class, and then go desserts. Not desert, desserts. Perfect. And a handy dandy tool that that IntelliJ, I'm getting all my words mixed up today, that IntelliJ offers us is that, look at this, we can click interface and then press enter. Oh my gosh, 30 milliseconds saved. Thank you, IntelliJ. At the very top, we see that public and interface are inserted for us with our keyword dessert. And now we're going to go ahead and start implementing our interface. We need to start writing the contract for our children. As we already said, we're going to say void. Then we say judge's reaction. Open and close parentheses, and then semicolon. That's how we begin writing it. Let's take a little quick deep dive into what this is. This is a return type for our method. It doesn't have to be void. It can be string, int, whatever you want it to be. And then here's where we put any parameters if we wanted to, or tell them to pass into our method at any time. And then of course we end it with a semicolon. We're not going to define any functionality, so always end it with a semicolon. The other thing we had was our default. And I always forget the annotation for this guy. What did I put in there? There you go, default int score. Int score, and I said 10, so return 10. Awesome. So there we go. We just successfully created our first interface. Any questions about this? Nothing at all. All right, all right. Now we're gonna go over to our cake class here. My question over to you all now. How do we take that interface and place it here for cake? I wanted this child to abide by that contract I just built. What do I do?
Public class cake implements dessert.
Very awesome job. Public class case implements dessert.
If you put in parameters on your interface, would they have to also be abided by in the cake?
Absolutely right. Yep, that is that contract that you wrote for them. So yes, they will have to put those parameters in there. You can take a look at that too if you'd like. So real quick, we see that we got an error here. The error is saying that the class cake must either be declared abstract or implements abstract method judge's reaction. It's giving us two possibilities. Either we have to say public abstract class, which what happens is that now my abstract class doesn't have to abide by my interface. Abstract classes don't have to abide by that contract, but the children do, which means that what my parent just did is like, okay, I don't want to worry about it. I'm going to push my debt off to my children. And therefore we go over to chocolate cake. Here it is with this error saying, now I must implement judge's reaction here. So take a close look at this behavior. That when you place an interface on an abstract class, it's going to pass that contract down to its children and demand that those methods get implemented. But let's go back to cake real quick. I'm going to take off abstract there. We're going to go ahead and just put in judge's reaction here. Public void UDG action. There we go. Amazing. So there you go. Why are you all of a sudden? No, you're lying to me. Yeah, you're lying to me. Stop it. All right, there we go. And now once we implement that method, the error is gone because we have fulfilled the contract. We have created our judge's reaction. A question we got was, okay, what if we placed inside of our dessert? By the way, take a close look. Interfaces are green with an I in them in IntelliJ. That's a good way to differentiate. What if they wanted to pass in the score? What if we said, okay, they pass in the score, and that's going to tell me exactly how to react to the judge. So we go in here into cake, and we see that our error is still there, or came back, because now we have to add down here int score into our method in order to abide by that signature that was brought to us by the interface. And now the error goes away again. Look at all that. I'm using extra nerd terms today too, so please let me know if I'm like, Kyle, calm it down. Like you're saying implements way too many times. I know, sorry, I'm trying here. All right, those are just a few examples. We have some time left, luckily, and if we, oh, let me make sure. Yeah. There we go. Yeah, that's the last guy. I think it's hilarious. All of it was British grade baking show or whatever. So let's go ahead and go back to our code here. And what questions do you have about interfaces, about abstract classes, about polymorphism? Because these are topics that are are a bit of fun, let's just say, to the very least, but they also drive the power of Java. So I want to make sure that there's good understanding behind it. So anything you guys want to see, I'm here for, since we have some time at the end.
I have one question. If you were to go over to the program class, how would you call or use some of those different, I guess, methods that are within that dessert class?
Absolutely. So now that we have access to, now that dessert, if we look at our lineage, dessert's at the top with the one method that we have called judge's reaction. Then we have cake as the parent. So we'll say dessert's the grandparent, cake is the parent, and then chocolate cake and cheesecake are the children. So to answer your question, how we access that is just how we access everything else. If I wanted to get the judge's reaction, I'd say dot judge's reaction here. So if I ran that, we should get back amazing. And I'm able to do this because one, cake is the general class that implemented judge's reaction, but also remember that my cakes, chocolate cake and cheesy, are children of cake. That is a child of dessert. So judge's reaction got passed down to my children. So to access it, you just use the exact same dot notation that we have been to get that method. We see that we get amazing twice. So any question about that or anything else you want me to deep dive into, I'm happy to do so. Anything at all, or does that answer your question?
There's a couple questions in the chat.
Seeing it. I saw that I did see the most important topic that, yes, it is called I think that's truly what it's called. It's called the Great British Bake Off. I'm just terrible at remembering names. All right, besides syntactical differences, what are the difference between the following lines? And it's array list and list. That is just as if I did, instead of saying chocolate cake here, I just put cake. Syntactically, they are different, but also remember that you are declaring a general list class there. So technically, when you do that, you would lose any of the specific methods within the cake or within your chocolate class. That is the downside of it. Let me double check that I am not. So what I'm getting at here is that take a very close look at what I just did there. I am now creating a chocolate cake. I'm creating an instance of chocolate cake and I'm putting it into a generic cake variable. Now take a close look at what we're gonna do. We're gonna go to chocolate cake here. I'm gonna say public void hello. And whatever, we're gonna just print out something. What's your problem? Oh, AKA it was a test. It's quotes, thank you. All right, going back over to program now here. I want to call to this hello method, whatever. I go in here, I go to my chocolate cake. And I see that I have no access to hello. What just happened is that I can use the generic classes. It's very powerful to do that. But the second I do, I lose the power to access my specific methods within my specific classes. So Maylin, to answer your question is that those are syntactically different, but the bottom line, the one that just assigns array list to list, might be limiting its power because it removes accessibility to all of the customized methods for array list. Hopefully that helps. Regan, can you do an example with a comparable to and the compare? I would actually have to double check on.
Yeah, it's in the text. It was
Is it?
in
Okay.
it's like interfaces in the wild, and they were very similar almost. So I just wanted to see if there was an example.
I think I should look it up.
And also the comparator is a really weird word, but yeah.
Let me see real quick. Let me see if I can actually help. I have to see what the text is getting at for that. There's this object with this beside object order. Oh, okay. Is it talking about the comparable interface?
Yeah, I think it's like a built-in.
Oh, okay. Is it talking about implementing the comparable interface into something specific in the text? What was it? I have two things to explore now because I didn't see that in the text. I apologize.
I think the first part of the chapter was about how this all ties together and how to use interfaces that are already built into Java.
Got it. Okay. You know what? Let's go. Why not? Let's go ahead and do it. Let's go into our cake class and we can implement comparable. Did they implement comparable, or what interface did they?
Yeah, they did comparable, and then they did a comparator. Also an iterable.
Okay, yeah, we'll do comparable. An iterator is one for lists, but basically what it is that so what they're trying to teach you is that you can take those interfaces that are meant for specific purposes, such as comparable or iterable, and you can bring them into your customized class to use polymorphism or override to customize it to what you want to do. So comparable, let's see what functions it needs, implement methods. All right, looks like compare to. Okay, so it's gonna, I'm assuming compare to, so it's gonna compare this cake class to whatever's passed in here and kind of see what the differences are. So what I would have to do is that basically write the comparable method. I would have to first see is, okay, is O equal to this? Is the same thing, return whatever it says ent. So I actually don't remember exactly what the comparator does or what its return method is supposed to do. So you caught me in a bind because I haven't used compare to in quite some time. But that would be what I would say it's getting at. If you want to do specific questions, let me know about compare to. I can help you out. But yeah, I apologize. I can't do it. Iterable and me don't get along, and the compare to I have not used in quite a moment.
So you're saying we don't need it? You kidding?
Well, it's just saying that there's another tool in the toolbox. That's what they're trying to say. It's like there will be chances that you do need it. I haven't had any yet that I need them for, but compare to is quite popular in some applications, and iterable is extremely popular. So yeah, there might be cases. So don't forget it, but take my explanation with a grain of salt because I just haven't been in Java in a year or two, like formally or professionally. So I have not had to get into that. All right.
Noted. Got it.
All right. Okay, so Vinrod, can we declare abstract class as static? Ooh, let's see. I don't know. I'm trying to think if you could. I don't think you can. I think you can create any public static abstract. Yeah, I don't think you can create static classes because that's contradicting it. These classes are not meant to be static. Classes are meant to be initialized. So Vinrada, if that didn't answer your question, please let me know. And I'd love to hear some elaboration what you want to see specifically. But no, we can't create static classes per se. We can create static methods and static data or class variables within our classes, but not a class itself. Okay, so Pooja, can you use extends and implements at the same time on a subclass? And subtype. Okay, yes, you can. You can implement and so you can implement. Oh, this is also one thing I forgot to mention too. You can implement as many interfaces as you want. You can only extend one abstract class. That's one big note to take. So we create an abstract class here. Let's go ahead and hop into, take out this. Let's go into chocolate cake and help out. So extends cake and implements the dessert. So what this is doing is that I'm extending chocolate don't exactly know what you're complaining there. So implements dessert and extends cake. Technically, you should have gotten an error here. Why are you not? Why are you not mad? You should be mad. Oh, okay, because abstract, I was like, why? Because abstract class is already doing it for us. I was like, why aren't you mad? You should totally be mad about that. There we go. Now it's angry. So what happened was that over in cake, I was already implementing the judge's reaction. And because we extended it into chocolate cake, it actually completed the contract with our interface. So it wasn't getting upset. I knew there was going to be mad. Like it always gets mad. It was like, what's going on? So I forgot I implement that over here. So we take that out on cake. We go over to chocolate cake, and we see that we're getting the error because we are not abiding by the contract that we've established in our interface. Also, you gotta notice I stumble over implements and interface, and it will happen now for the next like class or two. It even happened last time. So now that I implemented judge's reaction here, I'm gonna do a system.out.println. Wow, there we go. So now once I do that, all the problems go away. Of course now, yeah, because I didn't put that in. Oh, yep. Did I still have that in there? I do. For chocolate cake, take a score. Oh, because cake is not in the general class, and we already talked about why that is a thing. I'm going to just comment that out. What's going on in that error is that I'm calling judge's reaction on cake, the general version of cake, and judge's reaction is not there. So going back to the original question, can you extend and implement it at the same time on a subclass? You absolutely can. Absolutely can. So great question there. Okay, so Malin, to your question, and it looks like some people might have answered this already. When should we do each of the 2 lines declaration? Is there best practice? Again, it always goes down to, do you need the customized classes or the specific classes within array list? If you do, you should go with array list. Honestly, by standard, technically, you should always declare it with a more specific class. To truly answer your question, you should always go with a more specific class. In the example we're doing here, I should always go with cheesecake, or I should go with chocolate cake. I should go to the very specific one. I should not use the general class by typical convention, just because you don't want to limit yourself if you don't have to. All right, everyone, that is all the questions there. Any other questions we have here before I turn you over?
I have a quick one just to kind of clarify. If I have a parent class, and this may have already been talked about, if I have a parent class that implements an interface, and then I create a child class of the parent class, does the child class have access to the interface?
Absolutely, because the parent class defined it.
Okay.
So yeah, the parent automatically passed down the child's those methods to the children. Therefore, the child doesn't have to abide by the contract or do anything about it. They won't get an error because the parent did everything for them.
That's why those are so powerful. I got you.
Yeah, we're getting into the weeds now for sure with this. It's fun. Great question. All right, anybody else? Going once, going twice. All right, sold to the small groups on studios. Awesome job, everyone, today. Fantastic. So that was inheritance and that was polymorphism. I hope those words are a little bit better for you. So that's all I got for you, everybody.
An announcement before you.
Oh, sorry, Greg. Yeah, go ahead.
Those things down. Yeah. So hi, everybody. Exciting announcement tonight. We have an official date for graduation. So graduation will now be on November 29th. I'm going to post this in the Slack announcements channel, but we are looking at the dates. The November 18th will be the last day of class. It will be a work day. It will also be the last day to submit assignments. and then graduation 11/29, and liftoff will be starting on December 2nd and running through February 3rd of 2022 with some time off for the holidays. I will again post all of this in announcements, but if you have any questions, feel free to Slack.
Awesome. Hey, and Greg, also real quick follow-up question that we got in the beginning of lecture here. And this is my fault too of having the calendar wrong. Monday is not catch-up day, correct? That's still lecture, and then Thursday will be catch-up day next week.
Let me double check and make sure that I
Also, will you have him answer the question that I asked at the beginning?
Sure. Okay. We'll also ask that one. Cool.
Sorry, I just want to make sure.
No, you're good.
I lost my tab. Yeah, so Monday is not a work day. It is a class 8 day. And then Thursday is the work day.
Sounds good. Awesome. Then I apologize for that miscorrection or that issue in the announcements. Yes, we will have class Monday. Greg, one more question. There was a question from a student here in lecture that if they are feeling that Unit 2 cannot be completed, is there a way to resubmit or reapply, or what's the process for that? So they want to come back and try again.
Yeah, so we take that on a case-by-case basis. We typically don't guarantee spots in future classes, but depending on the circumstances, the best thing for the student to do would be to reach out to me via Slack, and we can book some time on my calendar to talk about it.
My question specifically was if we aren't able to finish Unit 2, since we already passed Unit 1, would we be able to request to just, if we get a spot again in class, then would we be able to just like skip Unit 1 for the next session and go straight to Unit 2, like start at Unit 2?
Typically, we don't do that because we find that if people take that much time away from the curriculum, away from coding, they have a hard time jumping back into Unit 2, having been away from Unit 1 for that long. So typically we do, if you are admitted to the class, we want you in both units.
Okay. Thank you.
Awesome. All right. Fantastic. In that case, thank you, Greg, for that announcement. And thank you, everybody, for their questions and participation. That is the end of class. Let me go ahead and stop.